Here are the answers beginning with page 61. Question number 1. We're asked to give two interpretations of this expression, which is the 4x sitting here. And for each interpretation, indicate a suitable or realistic domain for the situation. For my first interpretation, I'm going to be very literal, not attempt to make any real-world scenario, but just to express these symbols in words as 4 times a number x. Because there's no real scenario attached to this, the number x could be any real numbers, and that's my suitable replacement set. X could be an element of the real numbers. For a second interpretation, I'm going to write something more real world, where the letter X represents something from a real situation, perhaps 4 times the number of students. This expression talks about the number of students, so it's more real life. We don't know how many students there are, and that's why it's a variable, the letter x, which represents that object. In this situation, the real numbers is not a suitable domain because real numbers include negatives and fractions, and that doesn't make sense if x is the number of students. The only types of numbers that make sense in this situation are the whole numbers, because you could have 0 students or 1 student, 2 students, and so on. So this time, a suitable domain is x must be an element of the whole numbers. Number 3, the algebraic expression is x plus 2. For one interpretation, let's literally write that out in words, x plus 2. There are many other things that could have been written, such as the sum of x and 2, or 2 more than x. In this situation, where the letter x is representing some completely unknown thing, a suitable replacement set is to say that x can be any real number. For a second interpretation, again, let's try to create something more real world, where the variable x is representing some real object. Here's an example. 2 more than the number of pizzas. In this case, the letter x is representing this unknown number of pizzas. When we consider the domain, suitable numbers that you could use for number of pizzas would include anything 0 or positive. Because it's possible to have a fractional number of pizzas. You could talk about having 2.5 pizzas, but having a negative number of pizzas does not make any sense. So a suitable domain might be any non-negative number. Number 5, for our first interpretation, let's just say out in words all of these symbols. 3 times a number r, minus 4 is equal to 19. Because there's no real object associated with the number r, a suitable domain for r is that it could be any of the real numbers. For a second interpretation, let's create something from a real-life scenario. Here's a possibility. 4 less than 3 times Robert's age is 19 years. In this sentence, Robert's unknown age is being represented by the variable r. A suitable domain for Robert's age would be any natural number, because Robert could be 1 or 2 or 3 or 4 years old. Next, number 7. For one interpretation, let's just write out in words how you might speak that. A number g plus 2 times the sum of G and 3 is 12. A suitable domain for G is that it could be an element of the real numbers. Now let's create a real-world scenario that this expression might model. In our example, let's say the letter G is representing the number of gallons of gas. Here's a sentence. G gallons of gas plus twice the sum of G and 3 gallons is 12 gallons of gas. Because the variable G is representing the gallons of gasoline, it only makes sense if that is a whole number. You can't have a negative amount of gasoline. Number 9 is the last one of these kind of problems. First, the literal translation. You might speak this statement like this. A number x divided by 3 minus 2 is equal to 7. With no real-world situation attached, x could be any real number. Let's create a real-world situation that this algebra expression might model. Perhaps x is counting the number of A's a student gets. The number of A's divided by 3 less 2 A's equals 7 A's. In this case, the letter X is representing the number of A's earned in school. That must be 0 A's, or 1, or 2, or 3, and so on. So a suitable domain is that X must be an element of the whole numbers. For the review assignment, we're going back to page 59. We're asked to solve this equation. There's a certain pattern to this. On one side, there are things multiplied together. On the other side, there's a 0. The way this is solved is to set each factor equal to 0. Or the 6n minus 18 equals 0. And solve each of these equations. Subtract 14. And divide by 7 to get n equals negative 2. And this one over here, you would add 18. And then divide by 6 to get n equals 3. The word or connects these two results. So our answer is n equals negative 2, or it equals 3. Number 4 has the same pattern. Two factors being multiplied together, and the answer is 0. Set each of them equal to 0, using the word or to connect the pieces. Then solve these. This first equation is already solved for s. On the other equation, we need to subtract 196. And then divide by 14. Negative 196 divided by 14 is negative 14. The final answer is s equals 0, or it's negative 14. Number 6 has the same pattern of things multiplied together, and there's a 0 on one side of the equation. So write m equals 0, or 3m minus 1 equals 0, or 12m plus 96 equals 0. And then solve each of the pieces. First one is already solved. Here in the middle, we would first add 1. And then divide by 3 to get 1/3. Over here, we would first subtract 96 and then divide by 12 to get -8. So the answer for m is m equals 0 or 1/3 or -8. Next is page 55, the oral exercises number 2. There are 2 sets of numbers given. There are 4 numbers in the first set, 4 numbers in the second set. Some of the elements are the same in both sets, but they're not all the same, so they're not equal sets. In question A, we're asked to give the union. The union of 2 sets is the set containing every number that's in the first set along with every number in the second set. So our union must have the -3 in it, and the 0, and 1, and 2, and 3, and 4. This set contains every number from here or over here. The intersection set contains only the numbers that are in both sets at the same time. And those numbers are the 1 and the 2. Number 6, the first set has an R in it, a T, and an S, and the second set also has R, T, and S. They're not written in the same order, but they do have exactly the same elements. So in this case, the union and intersection are going to be the same set of numbers. The union is R, S, and T, and so is the intersection. For number 56, we have a compound inequality, an inequality with more than one arrow symbol. We want to solve it for S. Let's first subtract 9. 0 subtract 9 is -9. In the middle, when you subtract 9, you get the 4s alone. On the right, when you subtract 9, we get 16. Now divide by 4. We get -9 over 4 is less than s is less than or equal to 4. This combined inequality is the answer to this question. Number 18, let's solve for j. First, solve for j in this first inequality by subtracting 2. We get j is less than or equal to -3. Then there's an intersection symbol. Now go over here and solve for j by adding 3 to both sides. We get j is greater than or equal to -11. We want the intersection of these two results. We want to know all the numbers that are answers for both of them. It must work for both of them. So what are the numbers that are less than or equal to -3 and at the same time they're greater than or equal to -11? Here's that list of numbers. -11 works. -10, -9, -8, -7, -6, -4, and -3. Only these numbers satisfy the first condition and satisfy the second condition. Page 51, number 12, we're asked to solve and graph this inequality. First, let's do the distributive property. That will remove the parentheses. -6 times 2 is -12. -6 times s is -6s. Over here, 2 times 3s is 6s. And 2 times -6 is -12. Observe that there's an s on both sides of the problem. Let's remove it from the right side. So subtract 6s. We get -12 minus 12s is less than -12. Next, let's add 12 to both sides, because that will cancel that -12. We get -12s is less than 0. Now divide by -12 to remove the coefficient in front of s. We're dividing by a negative, so you switch the arrow. 0 divided by -12 is 0. We're asked to graph this. So make a number line picture and locate 0. Put an open dot and shade everything greater than 0. That is to the right.